Welcome back. Today we have this problem called range sum of binary search tree, or BST. Given the root of a node of binary search tree and two integers low and high, return the sum of values of all nodes with the value in inclusive range low and high. For example, if that we have the high and low is 7 and 15, basically what I want to do is that get all the nodes that in this range and just put the sum of them. So the sum will be 32 because the numbers are in this range are 7 and 10 and 15. 5 and 3 is less than that, and 18 is bigger than that, so we take this 3 characters. So let's just talk about how we can solve this one. I'll just add the text, and I want this one to be white. And okay, so what coming to my mind is that we do a depth first search. Yeah, we do a depth first search. Okay, depth first search by, let's just take this one. I guess 10, 15, 18, 10, 5, 3, and 7. Okay, 10, 15, and 18, and 10, 5, and I guess this one will be 7 and 3. Okay, and let's talk about how we can do this. So how we can can just start from the smallest one. We build a recursive function that we start until we with the deepest node that has no childs. Okay, the leaf node, and we see if this leaf node equals to in this range or not. And if this leaf node, for example, let's just say that we have this node, and if this node is equal in the range or not. If it doesn't equals to the range, maybe if this node is bigger than high. Okay, for example, if this node, let's say for example 5 is lower than 7, is not in the range, but it's a smaller than low. So what we should do there, we could first ignore this all section, because all of the left section is smaller than 5. So if 5 is smaller than low, all of the other section will be smaller than 5. And so we start with this one. We go to the deepest one, but we have to make this step in comparison in our calculations. And in the same thing, let's say that we have 18 and we have maybe like 20, and we have let's see 14, 16. Okay, and if we are in 18, I would say if this 18 is bigger than high or lower than 7, if this 18 bigger than high, that means there is no need to continue to loop through the right side, because the right side is already bigger than 18 because it's a binary search tree. So we don't have to loop through that. We only loop through 16, and it's we can go on and on. So how we can search this one? We do it with the recursion. Okay. So what we do that? First, I will say let sum equals 0, and I will return sum. And what I'm going to do is that I will create a function, a depth first function. Depth first, dfs, and this one will take the node and the high and the low. Okay, and I will say I will call, and this function will be a recursive function that it will call itself all the time, and I will call it here. I will call it with the node right now. It will be the root, and I will call it with the low and high. Okay, and I will see first of all, it's a recursive function. The first thing that we do all the time when we have a recursive function, that we do the base case. We just define the base case. I guess the base case here, it will be if we have no node. I guess if we have no node, like I'll say if node equals null, we just return nothing, just that. And I will say other thing. I will say if low is less than or equal node dot val, okay, and node dot val is less than or equal high. That means this node, the value of this node is in the range. What we do when we find this node in the range, we add it to the sum. So sum plus equal node dot val. Otherwise, if it's not the node is, if it's not in the range, we want to check if the node is bigger than the range, so we have to just cancel the right side. If the node is smaller, we cancel the left side. So we'll say if low is smaller than node dot val, I will say I will call this again. What will be with node dot left and we put low and high, and I will do the same. Oh, sorry, I will do the same with the high. If low, if high is bigger than node, so I will go with the right. Right, and yeah, I guess that's it. Why? Wait a minute, why? If low is less than or equal and not the val and high, let's say the high is not, and also if, wait a minute, no, this is wrong. If not the val is bigger than high, not high, the high all the time should be bigger than not the val. Oh, nothing worked. Okay, let's see what. If low less than not the val, and not the value is less than high. Wait a minute, and it will be, I'll call it in the right, low and high. If low is less than high and not the value, there is something wrong here. If not the value bigger than high, I will go with the left side, and if not that value bigger than high, I will go with the left side. If low less than high, I will go with the right side. None of them work. Again, I'm saying if low less than or equals not the value. Okay, well, let's say that we have 7 and we had, okay, and not the value is less than or equals high. And I'm saying if low is less than node dot value. I'll do just node dot left. Okay, and I will say if node dot value less than high, node dot right, and I put low high, and I put in the root low and high, and I'm returning some. Why it's not working? Why? 2, only 2. Ah, okay, doesn't equals run. I get that. Okay, there is something that I didn't look at the in the requirements. Just say by this one, I guess it will work. Okay, shit didn't work. Let's see why it's not working. Okay, let's see. This is if node doesn't equal null, and I'm doing if low just if low is smaller than, let's just give me a minute. Let me delete this function and just put it here, for example. No, because I need to use some. Just refresh, and let just some, sorry. Okay. So let's just discuss all the time with the recursion functions. It's easy to make a problem, and everything will be destroyed in your mind. So first off, we have sum, and we are returning the sum. And we're saying that if the node doesn't equals null, because the node code equals null. I didn't look at this one at all. Sorry about that. And I'm saying that, okay, if the node doesn't equals null, so I'll say low. If the node equals null, we just do nothing, like literally nothing. We'll say low is less than or equals. If low is less than or equals the node dot value, and node dot value is less than or equals high, that means we are in the range. So we add this to the sum. Let's see that we are not in the range. So what we should do, we should check if the low is less than node dot value. Okay, so that means that we continue on the left side. Maybe we find something something smaller, and it's in the high. So we take the left side by this one. We have the left side. For example, we have 15, and no, 15 is let's say we have 18, and the 18 is not in the range because it's low is less than 18, but however it's bigger than high, so we go to the left side. So I'm saying that if this is if this not and that means one of these cases are false. So I'm saying if low less than no dot value. Okay, so I'm checking if this first state is only true. If this one is true, let's go for the left side, because the left side is smaller characters. And I would say maybe this is not the case. Maybe the it's bigger than the range. If node dot value less than high, for example, maybe smaller than the range. If node dot value less than high, maybe let's go more right. For example, we have 3. 3 is less than high, but it's also less than low. So let's go right, because right is bigger than 3. It's bigger than the root. And we just continue to do that, to call this function until we reach the end, and yeah, that's it for today's video. I hope my descriptions got good, and sorry for the the miss that I have done in the middle. And that's it for this video, and see you in future problems.